I'm Larry Schultz, the Ares 1 project manager. I've worked for NASA for quite a few years, and over the years I've held a wide variety of jobs. During the shuttle development, I was the lead design engineer for the mobile launcher platform, and in that role I was able to lead the design, development, construction, and testing of all three shuttle mobile launcher platforms. The mobile launcher platform, or the mobile launcher, has a wide variety of systems, over 50 separate subsystems. And one of the most complicated subsystems are umbilicals. They are probably the most critical, most complicated, most time-consuming, and most expensive portion of the mobile launcher, except for the structure. And if you want to know what an umbilical is, it's the mechanical device that is physically connected to the launch vehicle or spacecraft and is connected to the ground and supplies things like propellants, liquid oxygen, liquid hydrogen, perhaps hypergols, air conditioning, power, hydraulics, and all of this sort of thing. Basically, we supply all the commodities, including power and control, to the launch vehicle during integration, test and checkout, propellant loading, and the countdown through T0. One of the challenges associated with the design and development of umbilicals is the testing. That's the final phase of the development work, wherein we not only validate the design but also the fabrication of the hardware. And a critical component of that testing phase are the umbilical plates. Historically, those umbilical plates have been designed, developed, and supplied to the ground for this testing by the flight hardware contractors. We had a problem this time with Ares 1 in that the program did not necessarily recognize our need for these plates, did not recognize the schedule that we had. In fact, we were perhaps a little tardy as far as identifying our needs, and we had some significant problems that we were not able to totally avoid or mitigate. We did mitigate some of the impacts of this by adjusting our schedules a little bit. We also agreed to accept something other than the absolute flight version of the umbilical plate. We were willing to accept a prototype plate and do all of our testing using a prototype plate, but that prototype plate would include all of the quick disconnects, the fluid connections, all the electrical connectors that would be on the first flight, but they would not necessarily have the final configuration. And depending upon the amount of changes, that particular approach could generate additional testing at some point, either during the development phase or after installation on the mobile launcher. The testing of an umbilical takes place at the Kennedy Space Center in the Launch Equipment Test Facility. That's a test facility that's been around since the shuttle development days. And what we do is that we do the fabrication associated with an umbilical. Once that fabrication is done, we bring the umbilical into the Launch Equipment Test Facility, install it, and do some functional tests. Then what we do is we connect the umbilical, both the flight and the ground plates, together and attach them to a vehicle motion simulator that simulates the worst case conditions that may be seen during a typical liftoff. And what we do is we disconnect and retract the umbilical in those 3 sigma worst case conditions to take and verify that we can do it in any condition. And once we test the extremes, then we know that we can successfully disconnect and withdraw separate from the vehicle and get the umbilical back out of the way so that we don't cause any problems during the liftoff sequence. Initially, this problem was raised when we identified what our need dates were for the umbilical plates, so that they would be available at the time the umbilical was installed in the LETF. What we were able to do is to adjust the sequence of the testing in the LETF to accommodate some delays by the flight. We also agreed that we could test a preliminary type plate that would perhaps not be exactly like the flight plate, but as close as we could possibly make it. It would have all of the flight disconnects, all the electrical connectors, everything that the first umbilical plate might have that's going to support the first flight. But we agreed that we could do without some of that, and that would allow us to take and do the testing that was necessary to take and validate the fabrication and validate the design. There could have been some additional testing required if there were significant changes from that set of umbilical plates to the final ones that were installed on the vehicle for the first flight. As a part of our discussion of this particular issue and attempts to mitigate this, we had a lot of discussion about, well, what do we actually need in the way of hardware, and we identified that we needed the flight plate and the ground plate with all of the various connectors, QDs and otherwise, and a piece of skin panel that would allow us to mount the umbilical plate to the motion simulator. And we had at that particular point embraced a BEA process, which was supposed to be the formal piece of paper that would allow us to acquire these umbilical plates from another center and a flight contractor. There is some risk for us, for the ground, for the umbilical testing program to accept something other than what may be the final flight configuration of the umbilical plate. There could be some change that would affect the disconnect and withdrawal sequence, mechanism, process that would not necessarily be tested if we did not have the final plate. And there would have to be some sort of a judgment made, not only by the flight but also the ground, if that situation did occur. Let's say that we tested to an obsolete version or configuration of the plate. There were a couple of additional quick disconnects that were added to the plate, and then there would have to be an engineering judgment made as far as whether those changes would be significant enough that would drive us to additional testing in the LETF with the final configuration of the plate that would be flying on the vehicle. Well, one of the things that we learned as a result of this experience was that we, the ground, need to raise the level of awareness within the program and within the various flight elements that this is a piece of equipment that we need early on, and that therefore sufficient resources and sufficient funding need to be programmed so that those umbilical plates would be available in time for us to do the testing, complete the testing satisfactorily, and then remove the umbilical from the test facility and install it on the mobile launcher, and do all that in time for the operational readiness date of the mobile launcher. And if the program recognizes the need, then they can program the funds. We can negotiate acceptable delivery dates for the umbilicals and get our testing done in time to meet our completion date for the mobile launcher. I assume that every umbilical that will be designed and developed for a future launch vehicle will need to be tested somewhere at some place. And so our program folks and the flight vehicle systems folks need to understand that there is an early need and that we need to focus our attention on meeting that need so that we can all stay on schedule and so that we can both be successful. If someone needs to get a hold of me, I would suggest that they try the global directory. I can be easily found there, and I'd be pleased to talk to anyone who has any additional questions about umbilical plates and the delivery.